All right. Okay, so um, there are two types of equations. There are two types of equations. Probably never heard the words explicit and implicit in terms of these, but we don't really call it explicit and implicit, but before calculus, but there are. You guys up till now have been working only with explicit equations, right? Explicit equations. A function can be expressed as an equation in terms of one variable. So I could solve it, x, y equals, right? F of x equals. That's how we've been seeing things here. Implicit are the function is implied by an equation. You can't separate the variables. They're so intertwined, like this equation here, the second one here, the one under implicit. Could I solve for y? Could I solve this equation for y? Why not? Why couldn't I? Mhm. Not because I'm missing x. Could I solve for y? Yeah. How can you isolate something when there's two of them? And I can't combine this guy and this guy because they're not like terms, right? So it's difficult to express y in terms of x. Okay? So implicit are when x and y are just in each other's business, right? Here, they're not. Here, x is to one side, y is to the other side. I can I can solve for x, I could solve for y very easily. Over here, how do we solve for y? We can't, right? So what we end up doing is flipping it. We solve for x instead. We can solve for x here. I can get this stuff to this side of the equation, right? And then I could take the square root of both sides and I can isolate x. So it's kind of the opposite of what you've been thinking so far, okay? When we graph these guys, they're not functions. Even though it says a function here, they're not functions. These are the graphs that kind of do crazy things, okay? And we're not going to look at graphs today, but when we do graph this guy, like if I were to graph this guy in Desmos, it would do some crazy stuff, okay? And it wouldn't be a function, okay? So um, that's the type of implicit. We'll look at some graphs, what they look like next week. But for right now, I just want to explain what is implicit versus explicit. Explicit, everything you've been given up to this point, and I'm not even talking about this class. I'm talking about every single math class you've ever had, any equation you've ever had, that's been explicit. Okay, it's been explicit. You've been able to get y by itself, solve all that stuff, all those rules that you guys have learned since math one, even before math one. You used those were explicit. Now we're going to look at implicit. Okay, so nice thing is it's got the same rules. We don't have to learn any rules. The rules that we learned last unit, power rule, product rule, quotient rule, sum and difference, chain, those all apply. Those all apply. These guys here, for those of you that can see it, they still apply, right? So we don't have to learn any new rules, but we just have to do a couple things before knowing that it's different. Okay, knowing that it's different. All right. Okay, so um, yeah, so when we were differentiating is just a fancy word for finding the derivative. Implicit equations, when we're finding derivatives of these guys, we use the same rules, but just a few modifications, and that's what we're going to talk about today. Okay. Okay, so what exactly? We see this all the time. You've seen this. If you had $1 every time you saw this on a homework, on a test, on notes, you'd have some money in your pocket. What does this mean? Why do we use dy? I know it means derivative, right? It means that's the derivative. But why do we use dy? Why is it dy? Why is it dx? Why is it a fraction? Does anyone remember? We talked about this one of the first days we did derivatives. We said this is what it means, but I don't know if you guys remember. You guys remember? Yeah, exactly. The y over x, y is the y over x. Exactly, because doesn't derivative mean slope, right? So that's why it's y over x. Good, good. That has something to do with it. So what does a d come from? What does a d come from? Kind of difference in y. Kind of what that means. It the first d, the top d, actually means derivative. dy, the derivative of y, right? So when I'm like this guy down here, this guy right here, which you can't see, if you can see on your paper right here, this guy right here, what are we finding the derivative of? Y, right? Okay, so that's why you see it there, right? Derivative of y. What does the other x, dx, stand for? What does the d down on the bottom stand for? So this is derivative of y. What does the bottom stand for? Does anyone remember? It's in your notes. If you looked way back, it's actually, I had it written in your notes. But like I said, it's been some time. We take this for granted. We take this symbol for granted. Anytime we see that symbol, oh, this is a derivative, or we need to find a derivative, right? But we take it for granted in terms of what it means. So this means derivative of y. This means with respect to x. With respect to x. That's what that means. Okay? So when we find the derivative using dy over dx, we're finding the derivative of the y equation with respect to x. What does that mean? What does that mean for this guy here? Because if I said find dy over dx, all of you would know what to do. So what my question is, what does it mean with respect to x? Exactly. That's exactly what it means. It means we're finding the derivative of y, right? Y is the name of the equation, or f of x, right? And we're finding the derivative of x's with respect to x, right? Up until now, we've kind of lived in the x world where x's run the world. We're finding everything has x. Everything has x, right? You could go back and look at your notes. Find the derivative of x. Find the derivative of x. We've lived in that world for so long that now we're going to kind of take a look at another world. And it's going to kind of seem a little strange at first, but it's the same rules. Okay? So when we do this, like when we do this guy here, when I find the derivative of this guy here, right? We say, we don't usually write this, but I could say the derivative of y with respect to x equals, right? And then I said, what's the derivative of 3x squared? 6x, right? And what I'm supposed to tag on, what did I just find the derivative of? What did I just find the derivative of here? X, right? So you know how I found the derivative of y over here? And I wrote dy over dx over here? What did I do over here? It wasn't a dy dx. What was it? Say it louder. Say dx over dx, right? That's what I did. That's what I did. Because the top is, what are you finding the derivative of? The bottom is, what world are you living in? Well, we're living in the x world. We have a bunch of x's over here, right? What am I finding the derivative of goes on top. So on top is, I found the derivative of x, right? On the bottom is, what world am I living in? I'm living in the x world. Now, why didn't I ever write that though? When I'm doing my test, when I'm doing my quiz, when I'm doing my homeworks, why didn't I ever write that? because then this guy here would be negative 1 dx over dx, and that'd be done, right? Why didn't I ever write those dx over dx's? Why wasn't it necessary to do it when we were doing it last chapter? Yeah, doesn't it equal just 1? Dx over dx, anything divided by itself just makes a giant 1. So I didn't write those. That's the exact reason why I did not write those, right? And we got 6x minus 1. And you stop there, right? And you're done with the problem. That's what we did. We didn't write those. I didn't bug you guys about those because it's just a 1, right? Well, now we're changing the narrative. We don't live in a dx dy, right? Some of you guys looking at the clock, if we just get started. We live in a y world now. We live in a world where they're going to be combined. X's and Y's are combined. So we have to make modifications. Okay? So now we're going to be finding derivatives of these guys here. Right? It's not an X world anymore. Right? It's not with respect to X. They're combined now. Okay? So when we're finding derivative of this guy here, let's start in the front. What's derivative of this guy, the first term? 2x. And I don't need to write a dx over dx because isn't that just 1, right? If I write a dx, you can, it's not wrong, but I wouldn't suggest doing it because it's just going to confuse you even more. So we don't write it. We just say, okay, minus. What do you think the derivative is going to be of the next term? Take a wild guess. 6y squared. You guys are right. What did I just find the derivative of? Y. So it's got to have a dy over dx. I can't cross that guy out now because it's not a dx over dx. Plus this term here, what do you think the derivative of this guy is going to be? Just regular old 4, yep. But it's got to have a tag with it because I found the derivative of y. Equals 2. What's the derivative of 2? 0. Doesn't have a y with it, so I just put a 0. Okay. Now, to find derivative, right, I have to find derivative. So when we find derivative, I got to find dy over dx, right? That's what I got to do. That's what the question says. Find dy over dx. How many of them do I have? Not a trick question. How many do I have? How many dy over dx's do I have? How many do you see right now in front of you? 2. There you go. Yep. Not a trick question, right? There's 2 separate ones, right? I have 3 terms. I have this term here. I have this term here. Oops. And I have this term here. I have 3 terms and then zeros on the other side. I'm not worried about 0 because it's just 0 right now. So the question is find the derivative. So I got to find this guy here. So I have to isolate that guy. I have to get that guy by itself. So the first thing I'm going to do is I'm going to focus on the one that doesn't have that tag. I'm going to focus on the one that does not have that tag. You're going to use your math 1 skills to isolate, right? Because that's where you isolated x. Well, this guy over here doesn't have that guy, right? So how do I get this guy out of Dodge and get him over here? What do I get? What's my math 1 skills going to tell me to do? Do the opposite, subtract. Good, so I'm going to do that. Subtract 2x from both sides of the equation. That goes away. I have a negative 6y squared with a dy dx tag on it, plus a 4 with a dy dx tag on it, and that all equals negative 2x. Okay? What can I do now to, because my end goal is to isolate dy dx. I want to have one dy dx over here, everything else on the other side of the equal sign. What can I do that you've done many times, not only in this class, but other classes, that would help me do that? I could do that. Yeah, you're right. I could do that. But I don't want to mess with those tags because I want to because if I combine them, so if I combine these two guys together, it's going to be one jumbled up mess. So let's leave them separate. I could do that. Okay, but I want to leave them separate. But I want to isolate them. What else could I could factor them out, right? Don't I have two terms over here on this side. I still have two terms, right? I got this guy plus this guy. What do they both have in common? What do they both have? They only have one thing in common. What do they got in common? They have that tag, dy over dx. So I can use division or called factoring, reverse distributive property, right? Reverse distributive property. So what I could do is say, okay, I'm going to divide this guy out. What's left in the first term when I divide this, when I divide a dy dx out? Mm-hmm. Negative 6y squared is left over there, plus, and what's left over in the other one? Positive 4. Good. Now, I only have one dy dx. So now I don't have a problem now. Now I have two over here, and I put them together because I factored it out because they both had one. So now, how do I get dy dx by itself? What step am I going to use to get dy dx by itself? Mm-hmm. Yeah, divide by what I don't need, right? This is distributive property. I have a distributive property problem, right? This is your classic distributive property problem. That's multiplication. The opposite of multiplication is division. So divide by what I don't want. So I get dy over dx, because anything divided by itself doesn't go away, it just makes a 1, equals negative 2x, negative 6 divided by negative 6y squared plus 4. Can I do this? No, I can't. Yeah. Can't do that because of the bottom. Because it's not just negative 6y squared, it's negative 6y squared plus 4. Right? So because of that, I leave it the way it is. I'm done. That's the derivative. That's the derivative. Okay. Alrighty. Okay, so let's do some more practice. Let's move on to example. That was kind of example number 1. So the real example number 1, here we got here. So right here, this tells you, this is what I'm doing. Finding dy over dx. Finding dy over dx. That means I'm finding the derivative. So how do I know if it's implicit? Well, look at my equation. X's and Y's are all stuck together. They live in the same world. That tells me, okay, I'm going to need dy dx's. I'm going to need those tags. Okay. So the first thing I always do is figure out what the heck's going on. Well, I have one term on this side, and then I have 1, 2, 3 terms over there. So I got to find the derivative of each. Okay, so the derivative of the first one, what's the derivative of the first one? The first guy, this guy here. 6y, right? 6y. What do I need to put with it? A tag, yeah, dy over dx, because I just found the derivative of y. X squared, derivative is 2x, right? Do I need a tag for 2x? Nope, because it's just 1. It's just dx over dx, so I don't need that. Plus the derivative of 2x cubed, 6x squared. Do I need a tag there? No. Okay, move on. Last one. Not y, 3y squared. Do I need a tag there? Yes, I do. Calculus is done. We're done with the calculus. The only thing I have left to do is isolate dy dx. Get dy dx by itself. Okay? Find derivative, get dy dx by itself. So I noticed on the test, I haven't graded the test, but I noticed on the test, the struggles had nothing to do with calculus. It was all you guys were trying to match the answer to the answers there. That's not calculus. That's why people say calculus is hard. No, it's not. It's the other stuff, right? I did my calculus, I'm done. Calculus is done, right? Now I got to isolate dy over dx. That's what you have to do, okay? That's not calculus. That's math 1. When you got x by itself, right? So I got to get dy dx by itself. So everything with a dy dx I got to get on one side of the equation. Everything without a dy dx I got to get on the other side of the equation. Okay? So I got a dy dx on the left side, and I notice I have a dy dx on the right side. So I'm going to put those two together. To get those two together. It's not a calculus trick, it's a math 1 trick, or math 2 trick, or math 3. There you go. Do the opposite. Inverse operations. Add, since it's a minus, I'm going to add this guy, because it's one term. I'm going to add it to both sides. On the right side, it's just 0, because I'm adding it. I'm just doing the opposite, so it's 0. So over here, I have 2x plus 6x squared. Over here, do I get 9x squared? No, I do not, because they're not like terms. I get a 6y dy dx plus a 3y squared dy dx. Okay, so now I got the dy dx's on the same side. What do I do now? Factor them out, yeah. On the left side, I see, hey, I have a dy dx on this term and this term. So if they both share something, I can factor it out. So I got a dy dx, and I have a 6y plus 3y squared, reverse distributive property. Don't wait for me. If you know what the next step is, do it on your paper. If you haven't already, some of you have already done this. What's the last step? Divide. Divide by what I don't need. Those don't go away, they become ones. But if they become ones, then I don't need to write them because it's just times 1. So I get a 2x plus 6x squared over 6y squared plus 3y squared. Now, again, that answer is 100% okay with me, but I can easily see on a test them doing this. 2x, 1 plus 3x over 3y squared. Um, wait. Yeah, I messed something up here, didn't I? Yeah, I added a y squared, right? Yeah, thank you. So it would be 3y 2 plus y. I can easily see them doing that too. Okay? Free response, either one works. I'm okay with either one. Multiple choice, you got to match it up with what they give you. The nice thing about multiple choice is the answer's there. They give you the answers. It's there. But multiple choice, I'm telling you right now, I've taken many tests. And the hardest tests you'll ever take are multiple choice tests. Because the answer is there, but they'll do things to disguise it. And then the others are called distractors for a reason. Right? They don't randomly put things on there. They know exactly the steps you're going to take. They know where students make mistakes. Right? They do lots of research to figure out where students make mistakes. And they put those answers there. Right? So, like I said, multiple choice tests are some of the hardest tests you'll ever take. So you really gotta, and it's not has nothing to do with calculus because you guys did the calculus. When I looked at some of the ones that some of the mistakes some of you are making, I'm like, wow, they did the calculus perfectly. It was the algebra that they had trouble with, right? So when they get their test back, they're like, man, calculus is hard, and I'm like, no, it's not. You did the calculus right. It's the algebra, right? Again, this is like the 5th time I've told you guys this. Why do you think we have summer assignments for this class? For the algebra parts, because that's where students mess up. After all these years of teaching calculus, that's where students make their mistakes. It's not with the calculus. The calculus you guys are great at. You guys know how to find derivatives, but how do I match my answers? How do I combine things? How do I factor out? How do I isolate dy dx? That's where students struggle. Okay? So just make sure that's why we do all that. Okay? All right, so next one. I'll do this one on your own. Do number 2. If you haven't already, do number 2 on your own. Okay, so if you're done, double check my work. Okay. So again, just modifications. That's it. Modifications to what we've been doing already. Ms. Bell? Mm-hmm. To the other side. Oh, okay. Yeah, yeah, that's right. No, you're right. Um, that's the thing about math. The funny thing about math is it's wrong unless everything is wrong. So if you get everything wrong, it's actually right. Because if, like she just said, she had the opposite of everything. If you have the opposite of everything, it's actually the same answer. It's the funny thing in math. You think in math, the more you're wrong, you're actually right. It's kind of weird that way. Okay, so yeah, that would be okay. Yeah, if you move it to the other side, obviously you're going to have different positives and different negatives. But yeah, if everything, that's another one of the things, right? Let's say you get a test and you have this is not your answer. You have this is your answer, and you're like, I'm done. And then you go A, B, C, D, E, and that's not one of them. The one Isabella just said is on there. You got to know that, oh, okay, this is the same answer. It's just the complete opposite. So it's just technically the same, right? Okay. Because it just depends on how they do it. That's a great point. Okay. All right. Okay. So this guy here, the next one. Okay. So take a look at number 3. Kind of the similar thing, right? Nothing new or anything. Does anyone see anything different about this one compared to the ones we've done so far? Yeah, the x and y are actually stuck together on this one, right? The x and the y in the very first term, they're stuck together. So when we're finding derivative of this guy here, what do you think we're going to do? Product rule. Yeah, product rule. If they're stuck together, right, that means multiplication. That means product rule. Okay? So the first term is this guy here. So be careful when you're doing product rule. The negative. Who does the negative go with? Both? One of them? None of them? Which one does the negative go with? Just which one? Which one does it go with? Just the x. Yeah, just the x. So it's a negative x. It's not times the whole thing. Sometimes you'll see this. Sometimes they'll throw one of these in and they'll say this. Then that's different. Okay. So right now it's just negative x. Good. Okay. So we're going to do product rule for the first one. Okay. So product rule says the first term times itself, first term by itself. So negative x times the derivative of the next one, the derivative of x. So that's y squared. So the derivative of y squared is 2y. Needs a tag though. Okay. Plus the opposite, the derivative of the first one, which will be negative 1, times the second one, y squared. Or negative y squared. It's just negative y squared. Okay, that one doesn't need a tag because I didn't find the derivative of y squared that time. Okay, so now let's go back to the problem. Plus the derivative of regular x is just 1. The derivative of regular 4 is 0. Minus 3y squared dy over dx equals 0. So you can kind of clean this up a little bit. So we have negative x times 2y. So this is what I'm going to do. This first term here is all multiplication. There's no addition or subtraction. So this first term here, I'm going to move the 2 to the front. So I'm going to say negative 2xy dy dx, because that's how it probably will be presented on a multiple choice problem. And then the next one is negative y squared because it's negative 1 times y squared minus y squared. Plus 1, there's no 0. I don't need 0. Minus 3y squared. Again, that had nothing to do with calculus. Everything out from here on out has nothing to do with calculus. It's everything to do with isolating dy dx. Getting everything on one side that I want, getting everything on the other side that I don't want, and doing it correctly mathematically. Okay? So, here's the river. Everything that does not have a dy dx has to leave. I don't need it. And to do that, I have to do it using the inverse operations. So I'm going to add y squared, subtract 1 to both sides. So I got negative 2xy dy over dx minus 3y squared dy over dx equals positive and positive. Oh yeah, sorry, minus 1. Yep, you're right. Yep, minus 1. Okay. Factor out dy over dx. That leaves negative 2xy minus 3y squared divide by what I don't need since it's just distributive property. Okay, done. Still use product rule. I didn't come up with any fancy rules, new rules, right? It's still the same basic rules, right? That's why the last chapter was called the basic rules of finding derivatives or differentiation, right? Because those are the same rules. We're going to use those same rules. I don't make up new rules. Okay? It's just the problems kind of look a little different. All right. Let's see. Try that one. I want you to do number 4 on your own. So double check my work if you're done. If you're not done, finish up and then check your answer here. Okay. Okay, so we've used product rule, power rule. We haven't used quotient rule. We haven't used chain rule, but those could come up. Okay, those could come up. It's not that we're not going to use them. How about those here? How about this here? So take a look at it before we even find derivative. First thing, for two things should be running through your mind. First thing is, are we going to use implicit? Am I going to need dy dx's for this guy? That's the first thing. Okay. The second thing is, what rules am I going to be using to find it before I even touch pencil to paper? Which rules am I going to be using? Chain rule. I'm definitely going to be using chain rule. What other rule am I going to be using? Product rule. Yep, product rule. Definitely product rule. And then just regular power rule, right? Good. Once you kind of formulate your plan, if you can kind of see where you're headed, it's a lot easier to get there, right? If you can kind of step back and see this is what I'm doing, you can see the roadmap ahead. That helps. Okay? So let's do this one. So we have, so on the left side, I have chain rule. This is the outside. This is the inside, right? So the first thing I got to do is find the derivative of the outside. What's the derivative of cosine? Negative sine. Everything else stays the same. Times the derivative of the inside now, the derivative of the yellow. That's where I'm going to utilize the product rule. Okay? So the 2 goes with which one? The x. It's 2x, yeah. So the first term is going to be 2x. The second term is going to be just regular y. Okay? So the first term times the derivative of the second term, which is just y, dy dx, plus, right? And I'm going to put this in parentheses because this whole thing is plus. The derivative of the first one, which is 2, times the second, which is y. So that whole thing is 1. The whole thing is 1. Okay. All right. Equals the derivative of y is just dy over dx. Okay. Calculus is done. Now we have to figure out a way to get the dy and dx's on one side, everything else on the other, and do it correctly algebraically. How are we going to do that? There's a couple different ways. Not just one way, there's a couple different ways. So how am I going to do that? How am I going to get dy dx by itself? It's by itself on one side, but it doesn't count if there's another one still out there. I got to have them all on the same side. There's a couple different ways to do it. What's one way? That's one way to do it. Yeah, that's one way to do it. Distributive property is one way because I have this guy out here times this in here. So definitely to get rid of those brackets, distributing would work. Okay, let's do it that way. So when I distribute this to this guy here, I'm going to get -2 sine of 2xy with a tag at the end, right? And then when I distribute this guy here with this guy here, I'm going to get another -2 y sine of 2xy equals dy over dx. That, yeah. Yes, I probably did. Yep, you're right. That guy right there. Thank you. Now, that was probably the most difficult thing I've done today, and that had nothing to do with calculus. Okay? That had nothing to do with calculus. That was just distributive property. How long have you been doing this? It's probably since 7th grade you guys have been doing distributive property, right? So that's what I'm talking about. A lot of times people get focused down on the calculus part being hard. It's not the calculus part that students struggle with. It's the things like this. How do I get dy dx by itself? Okay? So now I have no more brackets. I have this term here. I have this term here, and I have a dy dx over here. So what do I got to do now? Can I add the what? Add the 2y, the -2y you're saying? This whole first term here, add it to the other side? I could do that, yeah. Let's see, add, since it's negative, yep, I'm definitely going to add it. Sine of 2xy dy over dx, moving it over here. That goes away. So I have -2y sine of 2yx equals dx, or sorry, dy over dx plus 2x. Okay, what do I do now? Yeah, that's it. Yep, factor out the dy over dx over here. So that's just going to leave 1 plus 2x sine of 2xy last step. We'll divide by whatever I don't want to stay. right. Okay, so the last one we'll do on Monday. Okay, so on Monday we'll finish this up, and then I'll let you start on your assignment in class on Monday. And then, yep, the rest of the week we're going to finish implicit because there's other things with implicit that we still have to look at. All right. All right.